Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Planet X, Stellar Cores and Coronal Cavities. Now, recently some claims have been made that the solid objects belonging to the system of objects which I call the Planet X system, and which I also refer to as stellar cores, are coronal prominence cavities. So in this article, I will examine the term coronal prominence cavity, and I will show that it is a deceptive term, specifically designed to suggest that the darker circular regions produced within the sun's corona by solid objects are nothing but low-density regions contained by magnetic fields. And here we see what a coronal prominence looks like. It's basically a circular, darker region within the sun's corona, and it's surrounded by corona which is lighter than that region. Now, a solid spherical object in the sun's corona would, of course, tend to produce a darker region within the corona because it would occupy part of the corona whilst not giving off the same light that the corona it has displaced would, thus giving a very logical explanation for the appearance of a dark circular region in the sun's corona. And here's one of these objects which I refer to as stellar cores. If this object was due or could be referred to as due to some bubble, which the term coronal cavity may be suggesting, then this bubble would have to be three-dimensional. It would have to be a spherical bubble because we can clearly see that this is a spherical object. We can see the contours, the light along the sides here indicating, and the front here, an elliptical dark shape. So this is obviously a three-dimensional object, spherical or very close to spherical. So this would mean that if this could be described by coronal cavity, that coronal cavities would have to be a spherical bubble. Now, can magnetic field lines produce a spherical bubble in the sun's corona? Plasma loops and prominences, which are roughly in the shape of a loop, are often seen on the sun. These seem to be associated to magnetic field lines, but they never form anything that is even remotely spherical, and you can see that here. These are plasma loops. You can actually see that it's denser plasma that's flowing along these loops, and you can see lower density plasma which belongs in the corona. The denser plasma seems to come from the chromosphere, which seems to be in the liquid phase, and the same here with the prominence. But notice that there are no holes. There are no three-dimensional enclosed spaces. The loops lie along a two-dimensional plane, and the material making up the loops is simply denser than the gaseous coronal plasma at this altitude on the sun. And the same here. This forms a two-dimensional structure, not a three-dimensional structure. It does not enclose a three-dimensional space, a three-dimensional volume. So we do not, magnetic field lines do not seem to produce these spherical structures. And it is also extremely unlikely, if not impossible, that a magnetic spherical structure not associated with a spherical object would develop, because magnetic field lines exert repulsive forces on each other, so that any spherical structure of magnetic field not held together by a solid object would quickly fall apart, because they would just flow past each other as they repel each other. Now, in addition, the sun's corona is made out of gaseous plasma. Gas has a tendency to spread until the whole gas has uniform density. In a higher than normal density region, particles would tend to flow outwards, whilst in a lower than normal density region, particles would tend to flow from the outside inwards. Most of the atoms in the sun's corona are ionized, but neutral atoms are also constantly being produced. So containing a region of lower density is just about impossible, because in the maelstrom of particle activity, there will always be some atoms that are neutral for a time and are thus not affected by the magnetic field and cannot therefore be contained inside the bubble. These particles will thus move across the containing field and may then become ionized again, thus emitting light. And this is what's illustrated here. And of course, it's even more difficult to produce a low density region than a high density region, because there would be a lot more atoms out here tending to flow into the low density region, whilst here there is a limited amount, because this is a limited amount of space. So this means that making or creating a low density three-dimensional bubble inside the sun's corona actually impossible. Now let us look at some specific examples of stellar cores within the sun's corona. So here we see a striped object. We can see that the stripes are curved, thus conforming to the object's spherical surface, and therefore indicating that this is a spherical surface, that this is a spherical structure. And we know that it is impossible to create a three-dimensional bubble inside the sun's corona. So what we have here is a spherical object, and a striped spherical object at that. We know we have Jupiter in our solar system, which is striped. This object would be about half the size of Jupiter, but very similar, because it seems to have a lot of stripe, just like Jupiter does. And here's a LASCO C2 image where we see this circular outline, which clearly indicates that this is a spherical object. Because the circular outline is retained as this object moves away from the sun. And if it was a bubble formed within the CME, it would not remain as a sphere, it would not remain circular, because it just could not. There would be pressure from the outside, and as the movement of the corona would affect it, it would change shape. So this has to be a spherical object. Now, this object is not even inside the sun's inner corona, which only goes about to half a solar radius from the surface of the sun, and the size of the sun is indicated by this white circle. And you see the object therefore is about the same size as the sun. And so the object is in the outer corona because it's quite far from the sun in this image already. It is moving away from the sun with CME plasma. Now, how would an empty hole, if this object was an empty hole, maintain a perfectly spherical shape after moving such a distance from the sun's inner corona? And that is if it was produced by coronal cavity. If a hole in the sun's corona filled with nothing but empty space is impossible, how impossible is it to have one with the same size as the sun, and which in addition maintains its perfect spherical shape as it moves within high density CME plasma at a speed of about 700 kilometers per second? And here's a close-up of that object. You can see it's perfectly circular. You can even see some light seemingly being emitted from the edge here. So this is obviously a spherical object. Now, this is the 2007 stellar core which traversed the sun inside the sun's corona. And the way we know that it's in the sun's corona is the fact that the object does not look black in this image. It looks red. It looks completely red when it is in the front of the sun. Here it's entering the corona, so it's not completely red. But here we clearly see that it looks red, and that means that there's light being emitted by the corona, which is between the object and the detector, thus placing the object inside the corona. We can even see it entering and exiting the corona in several images, because the part that is outside the corona is still dark, it's black, whilst the part that's inside the corona is red. And this object was about 2.2 times the size of Jupiter. It traversed the Sun in 10 hours, thus moving at a speed of 39 kilometers per second, which is way below the Sun's escape velocity of 616 kilometers per second, suggesting that it does not obey expected gravitational law. And I've written a lot about that. You may look at this article 210 entitled Stellar Core Gravity, tidal, and G, the gravitational constant, is not constant. Would this object be described as a coronal cavity? The corona in front of the object seems to be in a much darker tone of red than everywhere else. You can see the color of the corona here. We can see the color of the corona here in front of the object, much darker. So it does fulfill the definition of a coronal cavity, which is a circular shape, which is darker than the rest of the corona. But this coronal cavity moves like a solid object within the corona, because it is of course a solid object, thus clearly indicating that coronal cavities are created by solid objects within the corona. And here we see the object as it enters the corona. You can see the part that is still outside the corona. You can see the corona that is in front of the object. You can even see the edge of it here. Of course, the corona forms a spherical type shell around the Sun. So you can see part of the object in the background of the corona that's further back, and therefore goes out a bit further from the edge of the Sun than the corona that's more in front. Next, we have the 2001 stellar core, a clearly solid object which eclipsed the Sun in 2001. It was observed in a Yoko satellite X-ray image. That's a Japanese satellite. And this occurred at the end of 2001. The two images are 8 minutes apart. This object clearly is emitting X-rays. Even here, when it's almost completely eclipsing the Sun, we can see large of bright dots indicating X-rays being emitted from the surface of this object. And we can also see that some of these X-rays show that close to the equator there are some curved contours on the object, and these seem to indicate a layer which is raised above the rest of the surface, indicating there's possibly some kind of stripe along the object's equator. Now, obviously, this is a spherical object. Only a spherical object would have these type of spherical contours on it. But some people have tried to claim that this object is the Moon, because on this day there was supposed to have been a lunar eclipse. Now, the Moon does not emit X-rays, but the Moon does scatter a few X-rays, so that in a very long exposure soft X-ray image, the Moon may look as shown here. And so this is in a very long exposure, and we would of course compare the dark side of the Moon with the object here, because this is the dark side of the object. This is the side facing away from the Sun. And you can see that there seems to be more X-ray photons coming off this object than are coming off the dark side of the Moon here. In addition, this image of the Moon, which is shown here again, is from June 29, 1990, has an exposure of 1,899 seconds. So in other words, and that's 31 minutes and 39 seconds. It took over 30 minutes for these many X-ray photons to be detected as coming from the Moon. And yet the Yoko images have an exposure of only about 1 second. So more X-ray photons were detected coming from the night side of that object eclipsing the Sun than the dark side of the Moon over a time period nearly 2,000 times longer. So clearly this is not the moon. This is a solid object which emits X-rays and has surface layers, at least one of which demonstrates a striped format around the object's equatorial region. Now, and furthermore, we can actually see contours from the object because these are emitted X-rays. Emitted X-rays are different from scattered X-rays. Scattered X-rays come off the object at many different angles, so it's very difficult to determine from which position the scattered X-ray came from, and this is why it's impossible to actually see moon features from an image like this, because where these rays came from is not clearly defined. So there is no way of visualizing any surface features. So in conclusion, the term coronal cavity was specifically designed to deceive people into thinking that the dead stars, the stellar cores belonging to the system which I have named Planet X, which have invaded our solar system, do not exist, are not found in the sun's corona, and will not in any way impact our life on Earth. However, as I have demonstrated in this article and in many other articles I have written, this cannot be further from the truth. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.